with inequalities, but we're going to throw in a little extra something, and that extra something is absolute value. So before we start, let's just do a quick, simple review of absolute value. Absolute value, remember, means the distance from 0 on the number line. So if I said the absolute value of 3, it is 3 spaces from 0 on the number line. The absolute value of -3, who can tell me? Izzy? 3, right? So remember, it's not opposite, it's always positive. Okay, so the thing with absolute value is that it changes, right, from negative to positive, but the positive stays positive. So what I'm going to give you for this to start is sort of a little key that I want you to use for how to solve these problems. Now, there's going to be more than one thing in the absolute value, and we'll start with an example in just a minute. But the first example or type of problem you're going to see is something in absolute value. Now again, it's going to be more than just an x, but this is sort of just a simplified version of what you need to look for to solve these. If you have something absolute value and you have an equal sign, or if you have something with absolute value and you have a greater than, or a greater than or equal to. It doesn't have to have the or equal to little line, but it's a greater than. If you have either one of these situations, you are going to write an or inequality. So thinking of what we did yesterday with the and the or. Now I'm numbering these because what I'm going to do underneath here is I'm going to then do an example of each one. So 1, 2, and 3, these patterns will match up with the examples that we do. So if you have absolute value of something equals a, now a of course is going to be some number most likely, or if you have the absolute value of something and you have a greater than or equal to whatever number, you're going to be writing or inequalities from those. If you have an absolute value and a less than or equal to, with or without that little line underneath, this is going to become an and inequality. So this is the first thing I want you to look at when you're starting is, for each problem you go, okay, is this a 1, a 2, or a 3? Is it an equal, a greater than, or a less than? And then you look to see which kind of inequality you're going to write. Now for each of these, there's a couple little things that we got to do. So what I'm going to do for each of these 1, 2, and 3s, I'm going to do a 1, 2, and 3 so you can match up the problem with the pattern. Okay? So the first one we'll do a 1 with an equal sign. Now I know we're doing mainly inequalities, but with an absolute value, that changes things just a little bit. So, for example, absolute value of y minus 2 equals 4. Now here's the reason we have to do two statements. Whether it's an or an and, it's two statements put together, just looking in a slightly different format. The reason we have to do that is, let me just go back up here, is that there's two different possibilities for what could be inside. If I covered these up and I said, oh, two things whose absolute value is 3, what could go inside? Well, there's two things. It could be a 3 or it could be a -3. Right? So there's two different possible answers of what could be inside the absolute value to both equal 3. So the idea here is there's two things. If I cover up this, what could go inside here? Pretend there's not a y minus 2 going on. What could go inside these absolute value bars if it were equal to 4? Jaden?
A 4.
A 4, or Luke?
2 plus 2.
Which is also 4. How about something other than 4 that could go in here and its absolute value would still equal 4? Jim? -4, right? So if I say, hey, we don't know what's in here, we go, oh, well, if its absolute value equals 4, it could be +4 inside there, or it could be -4. Notice there's two choices of what could go inside there. So that's why we have to do this. Now, if it's an equal, here's what you're going to do. Because we need an or, we need two statements. The first statement is, you just take off the absolute value and you rewrite it. Now, think about what we just said. If I covered this up, this could be a 4 inside, or it could be a -4. So here's the second statement. The first one you just take off the absolute value and you rewrite it. The second one, you take off the absolute value and you make the answer a negative instead of a positive. Or if the first one was a positive, you make this one a negative. You flip the sign on the answer. I don't know if my little yellow arrow is visible there. So be careful. You have to do this step. We're not going to write the same equation twice. There has to be a slight change. So again, it could be 4 or negative 4. The idea here is this answer is 4 or negative 4. Now all we do is we just solve each one. I add 2. My first statement, y equals 6, or second one, I do the same thing. I add 2, but now I get y equals negative 2. And let's prove that this is true. If y equals 6, 6 minus 2, okay, that's the absolute value of 4 equals 4. That's correct. If I plug in the negative 2, negative 2 minus 2 makes negative 4. The absolute value of negative 4 equals 4. These both work. Okay, so again, you look up here at my little legend, 1, 2, 3, we go, oh, it's an equal. Okay, I'm going to write an or. Then I need you to look at the example and go, what did I do on that? Oh yeah, we changed the second number to a negative. That's your first example. Questions on number 1? Okay, number 2. Now I'm going to do a pattern that looks like number 2. So again, something in the absolute value, t minus 3. And now greater than or equal to, this one will just say greater than. So it could be greater than or equal to, it could be greater than. This one, we look up, number 2 says, okay, I'm also going to write an or. So the first one, again, we do it exactly like we did with the equal. The first statement, we're just going to take off the absolute value and we're just going to write it down. So t minus 3 is greater than 2. Now on the second one, when we have inequalities, I not only need to make the 2, now I'm going to leave a little blank space there to put my sign, I'm going to make it a negative just like I did on the equal sign one up above, but I'm also going to flip the direction of the inequality sign. And that again has to do with that idea of if we multiply or divide by a negative, we flip the sign. So again, I'm trying to highlight for each example here, here's what you do. Look for the direction of the inequality sign to change, and you take that answer, that 2, and you make it negative just like we did on the equal sign one up above. Okay, so for each one, I want you to look at your notes for this, guys. I'm not asking you to memorize how to do these. I'm asking you to have good notes that you can look at. And now we just solve each one. Okay, I add 3, I get t is greater than 5. Or, same thing, I add 3, I have t, now it's less than 1. Now think about this for graphing. I'm going to graph this one real quickly. I can't remember if you have to graph on the homework. I think you might. 1, 2, 3, 4, 5. T is greater than 5. We would do an open circle and the arrow going to the right. If we did not flip the sign on this one, it would say t is greater than 1. And then our graph wouldn't work. Because if I had t is greater than 1, I would have the circle here and the arrow would also be going to the right. And how does that work? It can't look like that. So if you're graphing it and you see something like this happening, then it's like, wait a minute, I did something wrong. Just like on yesterday's graphs, t is less than 1 is what we actually have. So it goes this way. Your graphs today should be just like yesterday's because you're doing and or statements. Either they go in opposite directions or the next one you'll see it will join in the middle. But we can't have it where they're kind of both going the same direction, but that doesn't work. Questions on this one? Okay, last one. We just need to do one more. This will be our number 3 example. So again, absolute value, and this time less than. Absolute value of x plus 1 is less than 3. We see a less than. Now this said to take an and, make an and statement. So, with our and statements, remember that there was something in the middle and there were signs and numbers on the outsides, right? This was like the and statements you solved yesterday where the variable was in the middle. First of all, for the inequality signs, you copy whatever this is. If it's a less than, they're both less than. If this is less than or equal to, they're both less than or equal to. So whatever this sign is what both of them are. Now, here's the good news. You just take what's in the absolute value. Remember the variable's in the middle. And you take what's in there, you take off the absolute value, you stick it in the middle. And now, just like the other ones, before we were making this 3 into a negative on one of them, we're going to do the same thing here. We're going to have one negative 3 and one positive 3. And all you have to do is think about the number line. Which one would come first on the number line if we were going left to right? Negative 3 or 3? Vincent? Negative 3. And the positive 3 would be here, right? So again, visualizing the number line. If I had negative 3, 0, 1, 2, and 3, right, they would go like this. So that's the order. You're going to take whatever that number is after the inequality, you're going to make it negative as well. But the negative one should come first, because on the number line, that's how it goes. Now, how do we solve these? What did we do yesterday to solve an and statement like this? Because it's not solved yet. We've written it, but I haven't solved it. What do I need to do to solve it? Think about what you did last night. Luke?
Get the variable by itself.
Yeah, we get the variable by itself, and if I need to do -1 in the middle, don't forget we do -1 on all the parts. So then I get x in the middle by itself. I'm going to write the solution underneath. I have both less thans on the left side. -3 and -1 makes -4. And on the right side, 3 minus 1 is 2. So now to graph it, -4 is less than x, and x is less than 2. So the and statement has the 2 circles on the ends. This one, my number line's a little messy here. That's a -4 and a 2 for the final answer. And statements connect in the middle, or statements go in opposite directions. So for each one of these, make sure to look at the example of how you set it up. Because all you have to do is follow this pattern for each one. Take a look at each problem and decide, is it a 1, a 2, or a 3? Once you figure that out, look at your example of the changes that we made for each category. And that's all you have to do. Just kind of paying attention to what you're doing.